In this video, we're going to do some extra problems from Module 4. First part, we're going to do some problems from 7.1 through 7.4. So you can see this first one, I went ahead and denoted it's from 7.1. It's a rational expression. On my math lab, it would say something like simplify the expression, something like that. So what you want to do, the way you want to start out with this is factoring, okay? So you want to look at both the numerator and the denominator and see, can any of these factor? That should be your first step when you're trying to simplify a rational expression. So the denominator does not factor, right? It's y minus 6. It's just equal to y minus 6. The numerator, though, hopefully looks a little familiar to you and looks like a difference of squares, because it is a difference of squares. It is 6 squared minus y squared, right? And so if we break that up, remember, a difference of squares has 6 minus y and 6 plus y. And what this does is it makes our middle term cancel out, which is what we're looking for. The denominator has not changed, y minus 6. Now, we would want to maybe try to simplify this by canceling something out. And you cancel something out when you have something over itself, because that equals to 1, right? But right now, we don't have anything that's exactly the same. Maybe these two look pretty similar, but these don't look that different either. They're not exactly the same. The only way this works is if they're exactly the same. So what we want to do is look at y minus 6 and see, can we rearrange this to make it look like either of the top two? So I'm going to take it over here, and I have y minus 6, which I could also write as negative 6 plus y, right? That's just changing the order, but that doesn't look like either of the two on the top either. So now what I'm going to do is I'm going to try to take out a negative 1. Okay, and by take out, I mean I'm going to factor out a negative 1, which means I'm going to divide the negative 6, and I'm going to divide the y, both of them, by a negative 1. I'm going to write my negative 1 out front. Negative 6 divided by negative 1 gives me 6. A plus y divided by negative 1 is minus y. Now it looks like the numerator. So my numerator has not changed. 6 minus y, 6 plus y, divided by my new denominator is negative 1 times 6 minus y. And you see, if I distributed this negative 1 back through, I would have the same thing I started with. I would get a negative 6 plus y, which is the same as y minus 6. So remember that we're not actually changing it. We're just rearranging what it looks like, okay? It's kind of like if I have a $20 bill versus 4 5s. I still have $20. I have the same thing. It just looks different. Okay, so now this, though, gives me the same thing on the top and the bottom. 6 minus y over 6 minus y, and that cancels out. I'm left with 6 plus y over a negative 1. But anytime you have a 1 in the denominator, it's not going to be fully simplified. It's not considered a fully simplified answer. So we don't want to leave it like this. We want to go ahead and either distribute the negative through to divide each one by it, or bring it to the top. You could have negative 1 factored out times 6 plus y, or you could make this a negative 6 minus y. And that's by dividing both 6 by negative 1 and the y by negative 1. And either of these two answers should be correct answers for my math lab. Okay, so the next one here you see is a division problem. It says it's from 7.2. And the first thing you want to do again with division is to start with factoring. Okay, so we want to look, there's now 4 different spots we have to look at: numerator, denominator, numerator, and denominator. And we want to factor each of these spots. I find it's easy to work from left to right for me. That way I stay a little organized. So I'm going to start with the 4x minus 24. Hopefully you see they both have a common factor of 4. If I divide that out, factor it out, I get x minus 6 in the top here. On the bottom, I have 5x squared plus x, so they both have an x in common. I'm taking x out, and I have 5x plus 1, right? So I divide this one by x and this one by x, and that's how I get that, by pulling it out. If you remember with division, we're going to do keep, change, flip. So if you want to go ahead and do that in this step, you can. But if you're not comfortable with that, I would recommend that you wait. I'm going to write it all out. So I'm going to do divided by x squared minus 36. Here's that difference of squares again. Super, super important that you understand difference of squares and that you remember how to factor it. So you get x plus 6 and x minus 6. And then the bottom now is a slightly bigger factoring problem. So it might be helpful to write that one off to the side. 5x squared plus 31x plus 6. And you're going to do grouping is the preferred method where we do a times c. 5 times 6 gives me 30. And I'm looking for factors of 30 that combine to give me my middle. My first set of factors is 1 and 30, which happens to work for my middle. So this is fantastic. So I'm going to write it as 5x squared plus 30x plus x plus 6, right? I'm breaking this 31 down into a 30 and an x. If I combined these middle two, I would get right back to where I started. So this is module 3, that grouping idea, which is really an important method to know. I group them into two different parentheses. I look at my first one and say they both have a 5x, which is left with an x plus 6. Here, they don't look like they have anything in common. So this is an important part to remember, that every number has a number in common. Hopefully it's coming to your mind, and it's 1. So I'm going to write a 5 or a plus 1 here because every number has the number 1 in common. So that's always usable as a placeholder if they don't have anything else that you see in common. Now my x plus 6 is matched, so I have x plus 6 times 5x plus 1. Again, if I FOIL this back out, I should get back up here. So that's always a way to check. You can know if your answers are right before you start working or finish working. So now we have x plus 6 and times 5x plus 1. Now we need to go ahead and change this because we didn't change this to multiplication. We didn't do keep, change, flip. We need to write that step. So 4 times x minus 6 all over x times 5x plus 1 times x plus 6 times 5x plus 1. The denominator becomes numerator, and then numerator becomes the denominator. X plus 6 times x minus 6. Now what we want to do is look for things that are the same that we can try to cancel out, right? Because still anything over itself equals to 1. This is always true. So the first one I see is I have an x minus 6 here and an x minus 6 here. So those cancel out. Here I have a 5x plus 1 and a 5x plus 1. Those cancel out. Here I have an x plus 6 over an x plus 6. Those cancel out. I have 4 over x is all that's left. And that's my answer. Very pretty. Okay, so the next one now is from 7.4. The next two are from 7.4, and these are combining rational expressions. And they both, I chose two that didn't have common denominators, which means we're going to have to find a common denominator. You only have to find a common denominator when you're adding or subtracting. If you're multiplying or dividing, you don't have to worry about a common denominator. So please don't do that step. It's going to make your life a lot harder if you try to find a common denominator when you're multiplying or dividing. So addition or subtraction, though, we have to have the same denominator. So all we want to do, we want to look for the least common denominator like we normally would. And most of my students, when I ask them, when I say, what's 1/2 plus 1/4, they say, oh, well, the common denominator is 4, right? My LCD would be 4 in this one, and I have to multiply this one by 2 over 2. And I get 2 over 4 plus 1 over 4, and I solve my problem. And most of my students can get pretty comfortable with this process. But now we're trying to do it with letters and with expressions, and it's a little bit harder. So this one is 3w and w minus 3. Hopefully you see and understand that these two don't have anything in common. They're two different numbers. So the only thing I can do is make it 3w times w minus 3. Because they don't have anything in common. They're not factors of each other. And I can't just tack on a -3 or just do a 3 on the W. I have to multiply the whole things by each other, which means the first one needs a W minus 3 over a W minus 3, and the second one needs a 3W over a 3W. You cannot clear fractions because this is an expression, not an equation. So when we get a little bit further along, maybe 7.5, 7.6, we can do where we clear fractions because we have an equation that has an equal sign. When it's an expression, you cannot do that. So please remember. So I'm going to put parentheses here around this. My numerator on the left is going to be 2 times W minus 3. I'm actually not going to multiply it out yet. Save myself a little bit of work for a minute in case I don't need to. Plus 5 times 3W over 3W times W minus 3. So now you see my denominators are the same, which means I can now add them. So in the top on the left, I'm going to have 2W minus 6 over 3W times W minus 3 plus 15W over 3W W minus 3. And now normal fraction operation, my denominator stays the same. It all goes to 1, right? And I add my numerator, so I get 2W minus 6 plus 15W. And then I need to combine like terms, right? Because I have this 2W and this 15W, which gives me a 17W minus 6 all over 3W W minus 3. And that would be your final answer. If something could simplify, you should, but in this case, nothing can simplify because it would have to be an entire factor that would cancel out. You can cancel like factors. You cannot cancel like terms. So like this 3 and this 6 cannot cancel. So please don't make that mistake. All right, so the last one I have here is x minus 7 over x minus x plus 2 over 5x, okay? Again, we're looking for an LCD between these two fractions. A little bit easier because we have x and 5 times x, so we know that x is a factor of 5, or 5x, it's just 5 times more, so our LCD would just be 5x. So you have to think about it in those terms. Is one a factor of the other? You're doing the same steps that you would normally do for an LCD. It's just that we don't have numbers, we have more letters and expressions. So for this one, the LCD would be 5x because you have x and then 5 times x. So the right side has already got the LCD. So we just need to multiply the left one by 5 over 5. Again, I'm going to write 5 minus times x minus 7 over 5x minus x plus 2 over 5x. Now, another tricky part about this one specifically, when you have minus a whole fraction, like we have right here, you have to remember that this minus is distributed to both parts in the numerator. So what I like to do is rewrite this as plus, and then you can do minus with parentheses so that you'll remember to distribute this to both pieces. If you don't remember to distribute it, you're going to get the problem wrong because your numbers are going to work out different than they should. So this is another way to write it to help you not make that mistake. Change it to plus and bring the minus into the numerator of the second fraction. Now I'm going to multiply out, so I get 5x minus 35 all over 5x plus a negative x minus 2 all over 5x. Please don't cancel these 5's back over here. I see a lot of students do that. They multiply, they get the LCD, and then they cancel it back out. Well, if you cancel it back out, now you can't add them. So you want it to be unsimplified for a couple minutes while we're trying to work. So 5x minus 35 minus x minus 2 all over 5x. Again, combine like terms, so I have a 5x and a negative x, which would give me 4x, 5x minus 1x, and then I have a minus 35 minus 2. Again, this is I borrowed $35 from you, I came back and I borrowed 2 more. I didn't pay you back, I owe you more money. So minus 37 all over 5x. And that would be your answer. Again, nothing can cancel out, nothing can simplify, so we just stop there.